Performance itself has always been at the heart of the Ford Blue Oval, and there's only one car that really has been that showcases the dedication to performance within Ford, and that's the Mustang itself. Now that the all-new Shelby GT350 has evolved, it takes Mustang to a completely new level, and it's going to be the most track-capable Mustang that we've ever produced. The GT350 was engineered with the world's most challenging roads and racetracks in mind. Every single component and shape is optimized to work in unison together to produce performance. Last night, Joel told you about the overall goal of the program to become the most balanced, nimble, track-capable Mustang ever. We're going to let you drive that car today. To make this happen, we looked at every single component, system, vehicle response, and attribute that you can look at. That body, chassis, powertrain, brakes, everything that you can to make it work in unison to, again, drive the most performance we can out of the car as possible. Things like the car sitting lower in ride height, depending on what variant it is, it's 5 to 20 millimeters lower. The fenders are wider for the bigger tires. We've race tested the durability and the performance of the suspension itself, and we maximize the chassis tuning to, again, maximize performance. We're offering for the first to Ford continuously controlled magnet damping system on the GT350. We revised the suspension geometry and have a completely unique tuning. Springs, bars, dampers, bushings. We made major brake changes. We spent hours using computational fluid dynamics and wind tunnel testing to both design and validate our cooling system, and also the aerodynamics of the car altogether. An example of the aerodynamic work team has done are both the GT350 and the GT350R produce over 2 times the total amount of downforce than a Porsche GT3. The brakes itself are probably our most powerful and fade-resistant brake system we've ever put on a Mustang. It includes a 6-piston Brembo front caliper, 4-piston Brembo rear caliper. They're then coupled with a 2-piece SHW lightweight rotor, both front and rear. The front rotor is a 394 by 36 millimeter wide. The rear is a 380 by 26 millimeter wide rotor. The tires on the GT350 and 350R have been specifically engineered by Michelin with a lot of input from our vehicle dynamics team. They were able to create a unique compound and construction for both the Pilot Super Sport, which goes on the GT350, and the Pilot Sport Cup 2, which goes on the R, that met and/or exceeded all of our vehicle dynamics targets, our grip targets, and performance targets. For the GT350R, the unique tires are paired with a unique technology, which is the carbon fiber wheel. This is going to be the first-of-a-kind wheel offered by any original equipment high-volume manufacturer. It gives us an unprecedented chassis performance, improves vehicle dynamics, and it offers a 60-pound per car unsprung mass weight advantage with 40% less inertia. And of course, then there's the engine. The all-new, most powerful naturally aspirated Ford production engine we've ever done, 5.2-liter flat-plane crank, and 102 horsepower per liter. The high-revving 5.2-liter V8, flat-plane crank V8, allows for to operate more efficiently at higher RPM, which gives us more power. It creates 526 horsepower at 7,500 RPM and 429 foot-pounds of torque at 4,750 RPM. The flat-plane crank also offers a couple other advantages. It gives us lower inertia, so the engine revs quickly. The flat-plane crank in the 5.2 allows for about a 10% lower inertia than the base 5-liter. And it will deliver a sound that both enthusiasts and non-enthusiasts will grow to love. The engine is teamed with a lightweight Tremec 3160 6-speed manual transmission. The 3160 is about 10 pounds lighter than the comparably equipped Mustang GT 6-speed manual that's offered in that car. The internals of the 3160 are built for track performance as well. Triple cone synchronizers allows for rapid low effort shifts even at high RPM. And the transmission is built for track capability with a built-in G-rotor pump for transpooling. Now the GT350 is built for performance inside and out. When you get inside the car, you'll see that there's an interior that's optimized for performance as well. All last night mentioned the Recaro seat. We spent a lot of time working on both seat comfort and support. We have an ergonomic flat bottom steering wheel that's wrapped in Alcantara. And we have 5 drive modes, which I'll talk about here shortly in a minute. We have an innovative performance shift lane, which one of our engineers, Mike Magwood, came up with himself, created the idea, developed the technology, validated it, and now it's going into production. And he'll be here to answer some questions about that as well. And then, of course, we have the track apps, which are available on the base Mustang as well. I know you're really eager to get out of the car, because I want you to get out of the car too. But we set up the day's event. We set up the day's event so that you'll be able to do both on-road and on-track. Drive on the boat. So much feedback. One of the lights on. Sorry. So you'll be broken into 2 groups. I think you'll see that you have either a red dot or a green dot. You'll be able to experience the on-road in the morning session, or track in the morning session, or it's going to flip. So we're going to try to break into 2 groups, and then each group will do either on-road or off-road or track. The on-road route is great driving. It has this, you'll be able to drive on the Pacific Coast Highway. You'll have places to stop and do photography, so take your time and have fun with the car. I encourage you to try and do the drive modes. There are 5 drive modes in the car. There's normal, sport, track, weather, and then drag. Try the different modes when you're on the public roads, and you'll be able to feel and hear some of the differences as you walk through the modes. On the track, we're going to preset the car to track mode, which will keep the safety and stability control system on, but track mode opens up the yaw, the amount of yaw that you can have. It opens up the amount of wheel spin, so you're going to be in full control. But in case you do go over that limit, which I don't think you will, but just in case you do, the system will be there to protect you. You'll be able to drive both the GT350 track pack and the GT350R on the track and on the road. So you'll get to experience both in both settings. I think after today, Jamal and I hope that you'll agree that this car is by far the most track capable, balanced, and Mustang that you've ever driven. I think one thing I want to do now is introduce some of the key subject matter experts, because if it weren't for them, this car wouldn't be able to come together.
So, for engineers, we tend to communicate through targets, right? And the targets come from the vehicle level and they cascade down. So, for the engine system, the targets that the core performance team cascaded to us were 500 RPM, 8,000 RPM, or I'm sorry, 500 horsepower, 8,000 RPM or more, lightweight, and just a very broad torque curve. And that pretty quickly led us to, we looked within our stable what engines we have available, and it pointed us to the 5-liter family. And we pretty quickly settled on a naturally aspirated, all aluminum plasma spray bore 5.2-liter engine. Typically, when we do a naturally aspirated engine, I like to look at 4 attributes. It's airflow, basically how, for a naturally aspirated engine or any engine really, it's how much air can you get in. And for naturally aspirated, you can't cheat, right? You can't increase your density, you can't squander a bit of air. Pumping work, so once the gas is in, getting that gas out, and even actually the work it takes to draw in air, costs you power. Thermal efficiency, so once we have that gasoline and fuel mixture in there, how much will we actually convert to work? Is it lost out the exhaust system, or essentially lost its heat somewhere in the exhaust? And frictional losses, so mechanical friction, what it takes to rotate all these components and actually make the engine. So from an airflow basis, if you just think of it, from start to finish, coming in, coming through the open element air cleaner air induction system, and the air induction system typically roughly half of the flow losses occur in what we call the dirty side of the air box. The part where the air comes in, what we call the dirty air tube, into the bottom side of the air box, and then through the filter. So we just eliminated that, right? So that right there roughly cuts the flow losses in half from a conventional system when it goes to an open element system. From there, it flows into the 87mm electronic throttle body that has an aggressive board, which allows it to still idle nicely with such a large throttle. If you guys have done a lot of racing, if you have these really large throttle bodies, you notice that they have a hard time idling. So we work through that. You may not think so, but actually the plasma spray bore is probably the biggest enabler for airflow. And what that does is increase the bore size to 94 millimeters and allows us to fit larger intake valves in there. Also, since the valves are larger, from an engineering perspective, we want to lift those valves higher for them to work in their optimum range. And this engine has 14 millimeters of lift on both the intake and exhaust. And that is unheard of for a roller finger follower hydraulic maintenance-free valve train, much less at 8,000 RPM. So that helps us get the air into the cylinder. On the way out, as far as the interference on the exhaust side, the flat plane crank allows us to have less interference between cylinders and increases airflow as well. Once the gases are in, we have to get them out. So the exhaust pumping work and the exhaust flow, so we don't want any what we call residual gases that were burned in the previous cycle trapped in the cylinder for the next cycle. And we want to push those gases out the tailpipe as easily as possible. So we have larger exhaust valves as well, also benefited by enabled by the larger bore. And we lift them as well to 14 millimeters to quickly do what we call the blowdown. So the blowdown does not cost us any pumping work. That's when you initially open the exhaust valve and the gas is still under pressure and quickly finds its way out. Once the piston starts moving up, then we have to actually push that gas out and it costs us work. So one thing that influences that is what we call back pressure, the restriction of the exhaust system to the exhaust flowing out. And you'll see here on the underside of this car, Tom Technos can tell you all about it. We've got Wes Emnice, our NVH engineer, who does the sound. And typically these guys are at war with us for back pressure, but he was actually the guy responsible for both the back pressure and the sound. And you'll see there's no resonators. I hate resonators, and there are none. It's just a straight shot through, right? We have the catalyst all the way to the muffler, nothing but straight pipe, 1X pipe, and then we have an active exhaust that opens at wide open throttle for peak performance. So it's essentially a straight pipe out, and you guys will see how great this sounds. Just a totally unencumbered, natural sound out of this car. In terms of frictional losses, there are maybe some unanticipated things that can cost you power. One is the air moving around in the bottom side of the crankcase. And on a cross-plane engine, generally the air wants to move from what we call the front bay, cylinders 1 and 5, to the rear bay, cylinders 4 and 8. So there's this large amount of air because those are the two basic cylinders that are 180 out of phase with each other. And that costs us work to try to pump that air back and forth. And it's also carrying oil with it. It gives us issues with trying to get the oil back into the sump. So the flat plane crank engine, actually the two cylinders next to each other are 180 out of phase. And so they only have to breathe between each other. Much shorter trip and much easier for the oil to get by. To enable that further, we have added additional breather holes in the bulkhead. So those are the guys that are holding the crankshaft, the vertical parts of the casting and the engine block. We put more holes in there to allow the air to flow through easier. And we actually even gun drill the crankshaft. So we have a drill bit about this long, it goes all the way through the center of the crankshaft. It not only essentially gives us another breather hole, but it removes weight from the crankshaft as well in an area that doesn't affect stress and strength. Other frictional loss improvements we've done is these are the lowest tension, what we call tension cylinder piston rings in our history that I know of anyway. And most people probably don't know that the piston ring is actually the majority of the friction in the engine. So all the other parts rotate, particularly with our RF or our roller finger follower valve train, it's a very low friction. The rings account for roughly 40%. So our plasma spray bores are very round. We definitely hone, we stress the block and then hone the cylinders to minimize the distortion of the bore, which allows us to have a ring that isn't so springy, it doesn't have to push so hard to conform to the bore. And that allows allows us to reduce friction as well. So you put all these things together, and we have a 102 horsepower per liter engine that revs to 8250 RPM. So you notice this is classic engineering, we sandbag. So the targets were 500 and 8,000, and we came in at 526 and 8250. We're very proud of that. In the torque curve, I think this is the most impressive. You guys will see just how broad this thing is. It's very forgiving. As long as you keep it over 3,500 RPM or so, you won't feel the need, honestly, to shift very much. It's not required you to keep it on the pipe, between 6 and 8 grand or anything like that. It's very docile. I think it's very drivable for the novice. And you'll notice that the idle quality is as good as a Lincoln. This is not a rude, crude engine, right? It has outstanding emissions, it has great fuel economy, and idles like any of our other products. And yet, it is the fastest fitting production engine we've ever made. It's the highest specific output, actually has rated engine we've ever put in production. And it's really just a great, we've all had a great time working on it. So, our job was to put all the kinetic energy into the vehicle. Essentially, the engine is really just the thing that thrusts the vehicle, right? Adam Worth, the other Adam here, is now going to tell you how he dealt with all that kinetic energy and used it to get us around the track.
I'm Adam Worth, chassis supervisor for Ford Performance. I'm going to take you guys through some of the chassis content of the 350 and 350R. The philosophy of the chassis is pretty simple: make the most track capable car we've ever made. The actual execution is a little more complicated. So I'm going to go through the suspension. I'll hit front rear suspension first. I'll talk about our major chassis tunable springs, bars, and dampers. Then I want to hit the braking system, and then I'll finalize with the wheels and tires. So to start on the front suspension, the major difference here is actually our all-new aluminum front knuckle. We've taken the knuckle and revised all the attachment points in the front end of the system. So that includes everything from the link points, the tie rod, and the strut attachment points. The goal here was to increase steering precision and steering feel. At the same time, though, we need to make sure we reduce some of the negative effects that can occur from bolting on such a large front wheel and tire, things like rub under, parking lot efforts, right? That's what this aluminum knuckle allows us to do. Of course, in conjunction with that, aluminum knuckle is lighter than the Mustang GT and has greater wheel stiffness as well. Really, in the rear, we concentrated mainly on reducing compliance. So we had a great platform for the new independent rear suspension for the base Mustang GT. But really, we wanted to make sure we had the most confident feel of the landing rear end and power out of the corner. So the changes in the rear really are relegated to bushing stiffnesses. Our rear subframe bushings are completely revised, new rates. All of our link bushings have revised higher rates. Some other key bits in the back here are lower control arms, taken from the Mustang GT, are actually lighter than the Mustang GT control arms, and they incorporate counterwound springs. So I'll get into the chassis symbols here in a minute. Essentially, to give us our higher rates in the rear, we had to do handed or counterwound springs, just because of the architecture of the control arm. So just little features like that to be able to enable the spring rates that we want in the car. So I think to get down to major chassis tunable, you're going to find all the same common performance tricks here. So higher stay bar rates front and rear, and higher still for the 350R. You'll find higher spring rates front and rear, and higher still for the 350R. And then I think to spend a bit of time, we should really talk about the first active damping system we've put into a Mustang. Magneto rheological dampers, also called MR. People have asked me a lot of times, why do we just select MR for this system? I think the main reason is response time. So the MR system is able to vary its damping rate as little as 7 milliseconds for varying track conditions and off-road conditions. So, to give you guys a couple of examples of what the system can do, we monitor a lot of vehicle parameters such as vehicle speed, steering angle, roll, pitch, and yaw. And so the magnerized system can actually increase, say, roll damping in corner to simulate a larger stabilizer bar because it's monitoring that steering angle. And then roll, pitch, and yaw, it'll actually create anti-dive properties under hard braking. So you get more than just the damper, you get an entire integrated system. By using MR, we're able to integrate that into our drive modes. So think about the Mustang GT has its drive modes, so we take our drive modes a step further by integrating MagneRide as well as our exhaust modes. I think, I can't say enough about the brake system, but to be the most capable Mustang, we had to have the most powerful brake system we've ever produced. Up front, starting with a 394 millimeter two-piece in-drive aluminum pad rotor, coupled with a 6-piston radial mount integrated bridge Brembo caliper. Now, that's a lot, but I want to really stress that this kind of technology is really reserved for supercars. And it's all about trying to reduce the amount of caliper flex in the vehicle to create a consistent pedal feel. In the rear, we have the same theme, a 380 millimeter two-piece rotor made with a 4-piston fixed Brembo caliper as well. You know, there are no compromises with the brake system. That's important. You know, you're going to experience it on the track and on the road. Pedal feel is excellent, it's consistent, and it is absolutely fade-free stop after stop. Now, I think the last point I want to make is really hitting the wheels and tires that I think are probably the most important portion of what makes this car a track star. The GT350 comes complete with aluminum wheels, 19 by 10.5 front, 19 by 11 rear. Important to note that these wheels are actually lighter than the Mustang GT wheels, yet are 1.5 inches wider. So that's the same size. The tires themselves made into those wheels are the Michelin Pilot Super Sports 295 35 Series 19 front and 305 35 Series 19 rear. We partnered with Michelin specifically for this program. We believe they are the world leader in performance tires. And these tires are tuned specifically for GT350. So we have unique tread compounds, we have unique tread sculpture itself, and we have unique structure as well. You will not find these tires off the shelf in this one. Now, taking it a big leap forward, the GT350R comes complete with, as Gary mentioned, the first ever OE mass-produced carbon fiber wheel. This wheel was probably what our engineers spent the most amount of time on the chassis, and we're very proud of it. You know, I've been asked a lot about the weight. These wheels on average weigh about 18 pounds. If I were to make the same wheel in aluminum, same size, the wheel would weigh north of 33 pounds apiece. So we're nearly cutting the wheel weight in half. Gary had mentioned the inertial effects, 40% reduction. You know, it's something that I can't say enough about, but you know, in the pursuit for performance, you know, we have to go above and beyond into what's out there and find new technologies, and we're absolutely committed to technology, performance through innovation. Now, the tires that are made of those as well take it a step further. We're offering a Michelin Pilot Sport Cup 2 and a 305 30 Series 19 in the front and a 315 30 Series 19 in the rear. I think you guys are really going to be surprised at the amount of lateral longitudinal grip this tire is beyond anything that we've ever worked with before. And in fact, in our testing, these tires have outperformed a lot of aftermarket slims. So that's what it's saying something about the ability. So I think I did everything here, guys. I've thrown a lot at you. We'll be around all day. Please come to see me about any chassis aspects and Adam and our other SM.